Hi everyone, this is Mr. Mila, the science teacher. In today's lesson, we're going to answer a question from Science Paper 1, GCE 2024 paper. So we're going to start with question 1. And question 1 says, the diagram shows a simple pendulum that swings from A to C and back to B in 0.75 seconds. So we have our diagram there. So the question is, what is the period of oscillation? What is the period of oscillation? What is the period of oscillation? So what we're going to consider is, the first thing is to consider the number of oscillations. How many oscillations do we have here? So when you're looking at the simple pendulum, when it comes to calculating the period, we simply use the formula period of simple pendulum is equal to the time taken over the number of oscillations. Period is equal to time taken over number of oscillations. Period can simply be written as capital letter T, and then time taken small letter t. So we have that as our formula, which we need to use when calculating for the period of a simple pendulum. So now the next thing to do is, we have said we need to consider the number of oscillations. So how many oscillations do we have? We've been given the time already. We have 0.75 seconds. Now when it comes to the oscillations, how many are the oscillations? So how do we count oscillations? So a complete oscillation is going to run from A to C and then back to A. That is a complete oscillation, which means that we have one oscillation. Now in this case, the oscillation is incomplete. The swinging is ending at B. So it is moving from A to C and then back to B. So now, when we have this kind of a situation, what we need to know is, from this point to that point, it is going to make a quarter of an oscillation. A quarter of an oscillation. A quarter is simply 1/4. So from there to there, a quarter. Even from there to C, from B to C, that is also a quarter of an oscillation. From C to B, that is a quarter of an oscillation. So if we say a quarter, or 1/4 plus 1/4 plus 1/4, simple mathematics, common denominator, we know that is 4, and then we add these ones, we are going to have 3. So n is simply equal to 3/4. So now we need to deal with n so that we can be able to use it in the formula. So we're going to say n is equal to 4 into 3. In mathematics, we're going to say it can't. Grade 1, we're going to say it can't. So we put a 0 when you say it can't, add a point and add a 0 to 3, it becomes 30. So 4 into 30, that is 7, with a remainder of 2. 4 into 2, we are saying it can't, add a 0, it becomes 20. 4 into 20, that is a 5. 5 oscillations. So the number of oscillations is simply 0.75. So from there, we can now finally say period is equal to the time we've been given. The time is here, 0.75 seconds. So we're going to say 0.75 seconds over 0.75 oscillations. We don't even put it. So period is equal to 0.75 into 0.75, that is simply 1 second. So now, for the sake of precisions, we can be able to put 1.00 seconds as our answer. So that is how we deal with such kind of a question. It's a very simple thing to do. Just make sure that you follow Mr. Muller, the science teacher. You'll be able to learn a lot. Thank you very much. Thank you.